everybody, it's Mrs. Mancuso, ready to do practice exam 6. So if you do not have practice exam 6, I want you to go find the January 2016 exam. I'll write that up here. January 2016. So what I'm going to do is I go through a Regents exam with you. And I'm going to go over all sorts of problems and just go through an entire test with you. It usually takes an hour. I will keep this on my story, and I do also upload it to my YouTube channel. So if you go to YouTube and you search Nancy Mancuso, you'll see me, and then go to my playlist, and there's one called Chemistry Review. So again, I'm going to go through the January 2016 exam tonight. All right, so let's get rolling here. I have a calculator, I have a reference table, so ready to roll. Actually, I need a red pen. I don't like black pens. All right, which phrase describes the charge and mass of a neutron? So the first question is always something about protons, neutrons, electrons. So the charge, a neutron is neutral, so it just has no charge, and the mass is 1. So no charge, mass of 1. There we go. No charge and a mass of 1. What's the number of electrons in a potassium atom? So if you have an atom, the pluses and the minuses are equal, and the pluses are the protons. So you can just look up potassium. Potassium is element K. There's 19 protons, so that means there's 19 electrons. The number of valence electrons in each atom of an element affects its. All right, so let's just talk about valence electrons for a minute. Valence electrons are the last number, so 2-1. That tells us what's in their outer orbital, and that determines their reactivity. So things tend to react the same if they're in the same group because they have the same number of valence electrons. So we look at these. So valence electrons affect chemical properties. Absolutely. The number of isotopes is how many different atoms there are in terms of the number of neutrons. That's unaffected by their valence. Decay is unaffected by valence, and half-life is unaffected by valence. All right, nuclides 131 and 133. Oh, not 1, sorry, Iodine 131 and iodine 133. So that tells me it's an atom of iodine, and this one has a mass of 131, and this one has a mass of 133. They are classified as. So if you have two things that are both the same element, but they have different mass, they're called isotopes. So right away, I want just the two that are isotopes, and they are isotopes of the same element because they're both iodine. They just have a different number of neutrons, and that gives them a different mass. The elements on the periodic table are arranged in order of. So as we're going through these questions, I'm hoping that you're realizing, oh my gosh, it's the same every single time. Yes, they do very often ask the same questions over and over. They just word it a slightly different way. So periodic table, they're arranged by atomic number. 1, 2, 3, 4, 5, 6. That's how it works. Compared to a 1 gram sample of chlorine gas, a 1 gram sample of solid aluminum has. Okay, so if I have chlorine gas and I have solid aluminum, I'm talking about a gas versus a solid metal here. The aluminum is going to have lower melting point? No, because this has a much lower melting point. It's actually already boiled if it's a gas. Higher boiling point? Yes. Aluminum would have a much higher boiling point because it's a solid. All right, number 7. Which process represents one chemical change and one physical change? All right, freezing and melting are both physical. Freezing and vaporizing are both physical. Decomposition and melting. There we go. Decomposition is a chemical change. Melting is a physical change. Decomposition and combustion are both chemical. In the ground state, an atom of each of the elements in group 2 has a different. So here's group 2, our alkaline earth metals. They have a different oxidation state? Nope. they're all +2. They have a different first ionization energy? Yes. So ionization energy is the energy that you need to pull away the outermost valence electron. As you go down the group, the ionization energy would decrease because the atoms are getting larger. The valence electrons, they all have 2, and the number of electrons in the first shell, they all have 2. All right, which statement explains why water is classified as a compound? So if something is a compound, you have to have at least 2 different atoms, and they have to be chemically combined, and they are in a fixed proportion. So I always try to think out what I know about it before I look at their choices. So water can be broken down by chemical means. That's true. I said a chemical mixture, or a chemically combined, not mixed. All right, a liquid at room temperature does not make it a compound. Heat of fusion does not make it a compound. Poor conductor doesn't make it a compound. So the fact that they are chemically combined and they would have to be chemically broken down, that is characteristic of a compound. All right, which formula is an empirical? The word empirical means reduced. So let's see which one is reduced. A 1 and a 4. Yep, that's as simple as you could get. A 2 and a 6 could be decreased. 3 and a 6 could be decreased. 4 and a 10 could be decreased. So if you can reduce it, it is not it is not empirical. It's still molecular. Which compound contains both ionic and covalent? That means I want something from table E, if it's ionic and covalent. So this one is just ionic, metal, nonmetal. This one is just ionic, metal, nonmetal. CH2Br, that's only covalent. There is nothing from table E and there's no metal in there. Here we go. Na is a metal, Cn is from table E. Sorry, I looked at the N. NaCN is, the Cn is from table E, so this is polyatomic. These two, the carbon and the nitrogen, are in a covalent bond, and then they're negative, and then sodium with the negative is ionic. All right, what occurs during this reaction? Okay, so I'm writing BARF, broken, absorbed, released, formed. And so I look at what's going on here. I've got an H2 breaking into this. So when I break, I have to absorb energy. So energy is absorbed as they're formed. Nope. Energy is absorbed as they're broken. Yes. That has come up 6 for 6 exams that we've done. Parts per million is used to express the. So parts per million is on the back on table T. And so if you go to it, parts per million is under concentration. So it's used to express the concentration of a solution. According to table F, which ions combine with chloride to form an insoluble compound? All right, so I'm going to go to table F and I'm going to see who can I put with chlorine to be insoluble. So here's table F. Here's chlorine, normally soluble unless I put it with Ag, Pb, or Hg. So silver, lead, or mercury makes it insoluble. So there's silver. There's my answer. At 1 atmosphere, equal masses of water that's a solid, water that's a liquid, and water that's a gas, they do not have the same density. We know they don't have the same density because solid water is ice and it floats on water. They have the same distances between molecules. No, we know that is not true either, because if you have a gas, the molecules are really spread out, and if you have a solid, they're much closer. At 1 atm, equal masses will have different volumes. Absolutely. There is our answer. Because if you have 1 gram of ice, it's going to take up a very compact area, whereas the volume would be really spread out if you had a gram of gas. All right. Which list includes 3 forms of energy? So which ones are energy? Chemical energy, mechanical energy, electromagnetic. Yes, those are all true. Let's look at the other ones. Temperature is a way to measure kinetic energy, but it's not a form of energy. So we cross that one out. And pressure is not a form of energy. So that's why those ones aren't right. All right, next one. Oh, hey, Carlo. At STP, 1 liter sample of neon and a 1 liter sample of Kr have the same. So if I have 1 liter of each, that means that I have the same number of molecules. So if I have the same number of molecules, neon is 1 atom per molecule and Kr is 1 atom per molecule. So I'd have the same number of atoms. They don't have the same number of electrons because they don't have the same atomic number. So that wouldn't be the same. And their mass and their density wouldn't be the same because they're 2 different elements. All right, a reaction will most likely occur if the colliding particles have the proper. Okay, this is another one that is 6 for 6 exams. So that means every exam it's been on so far. So to have a proper collision, your molecules have to collide at just the right speed and just the right orientation. So orientation and energy. Which factors have the greatest effect on the rate of a reaction between aqueous silver nitrate and copper? So if I want to have the greatest effect, I have an aqueous and I have a solid. So right away, I'm going to cross off choices 2 and 4 because they have pressure. Pressure only affects gases, so I'm going to cross those 2 out. So what's going to affect them the most? The concentration and the temperature? Absolutely. Both of those are factors that affect reaction rates. The mass isn't. Okay, moving on. Which expression represents the heat of a reaction for a chemical change in terms of potential energy? So heat of a reaction is delta H. Delta H is equal to my products minus my reactants. So like if I think of a graph like this, where I end, subtracting where I start, that's my delta H. So this minus this. So for this one, it would be positive because this is endothermic. So I want to find products minus reactants. Products minus reactants. There it is. When a chemical reaction's at equilibrium, the concentration of each reactant and the concentration of each product must be. So I remember that saying, at equilibrium, my concentrations are constant. The rates are equal, but the concentrations have to stay at plateaus. Which element is present in all organic? If something's organic, it's got carbon. 2 types of organic reactions are. So deposition is a physical reaction. It's not an organic reaction, so not that. Polymerization and saponification, yes, those are both organic. They both involve, this makes polymers of molecules, so putting together a bunch of monomers, and saponification makes soap. So both of these involve carbon molecules. Given the balanced equation, what particles are transferred? So if I go from aluminum being a 0 to a +3, it's oxidized, which means that it's losing electrons. And this one's going from a +2 to a 0, so it means it's gaining electrons. So this is a redox reaction and it transfers electrons. 25, in an operating voltaic cell, reduction occurs. So red cat, so at the cathode. Reduction is always at the cathode, red cat. Which type of substance yields, that means gives, hydrogen ions in a solution? So what gives H pluses? Acids do. So go find the acid. Yep, and the definition of an Arrhenius acid is anything that donates H plus in a solution. Phenolphthalein is pink in an aqueous solution having a pH of. So I have to go to table M and I got to look up phenolphthalein and see when it's pink. So phenolphthalein is pink. It says 8 to 9, colorless to pink. So 9 and higher would be pink. So 12. According to one acid-base theory, NH3 acts as a base when it. So bases have 2 options. There's 2 definitions of a base. It either donates OH minus, which this does not do. It cannot donate OH minus because it doesn't even have an OH minus and it's not a metal with an OH. Or it accepts H plus. Either way, it's going to make your pH. So down here is like a 0 or a 1, like the most acidic is down here on this end, and 14 is over on this end. So anything that makes it go in this direction is going to be a base. So if you add OHs to it or you take H's away from it, you're going to make it go this direction. So it accepts H plus. That would be the definition of a Bronsted-Lowry base. Which reaction releases the greatest amount of energy per mole of reactant? So right away I think of table I, but then I look at these choices and they're not reactions, they're actual just chemical reactions. So decomposition, esterification, fermentation, or fission. Ooh, fission is what we use for nuclear power plants. That releases a massive amount of energy for a tiny little amount. Like I always say, you can have an amount of uranium that's about the size of this pen cap. You can get as much energy from doing the nuclear fission of its atoms as you could from an entire truckload of coal, which is why we're really trying to harness nuclear energy, because you get so much energy for such a small amount of uranium. All right, which nuclear emission is negatively charged? So there's a couple ways you can do this. First of all, a beta is negative, so that's definitely going to be my answer. But you can also look it up. Just go over here to table O and you look at what's negative. So there's a negative sign right there, and that's a beta. That's the only one that's negative. So you can always go to your reference table and try and find it. All right.